Hello everyone, welcome to the course Full Stack Machine Learning in AWS. I'm Sindhu Ghanta. I work as the head of machine learning at Tuxedo, where I develop ML algorithms for production monitoring. Before this, I worked as a research scientist at Parallelm, which was later acquired by DataRobot. At Parallelm, we pioneered the MLOps space, and I published several papers in conferences and journals on this topic. I got my PhD in machine learning from Northeastern University, and I have several years of experience in developing novel ML algorithms and publishing in various machine learning journals and conferences. I also have industry experience in building production ML pipelines and have worked extensively in production monitoring techniques. Here is an overview of the course. This course is a combination of lectures and hands-on labs that you can do live during the sessions. The goal of the lectures will be to cover different ML concepts at a depth that is sufficient for someone to get a high-level understanding. Focus will be to ensure that you can use these algorithms in the future to solve a huge range of problems in the real world by building production-grade pipelines. This course consists of 8 sessions. We are covering how to do full-stack ML, which involves not just training but also deploying the models that you build. We will show you how to build powerful AI services like the ones provided by AWS. We are going to do all of this in the context of various classification and regression problems using the inbuilt algorithms provided by AWS. We will also build custom algorithms using Dockers and learn how to bring such custom algorithms into the AWS SageMaker context. We will cover several AWS tools in the process of learning to build ML pipelines, starting from S3, how to store data, how to manage it and connect it to an AI stack, how to store models, etc. We'll also use instances, endpoints, lambdas, gateways, CloudWatch, etc. To manage the life cycle, we'll be using a bunch of other tools that are complementary to the use of AWS. We'll use things like curl and postman to do manual testing and automated testing of the REST microservice that you guys will build here. We'll be using Python scripts too for things like feature engineering. We'll be using a free tool, Tuxedo Navigator, to create fast iterations of AI lifecycle on AWS and use it to understand billing from AWS. The lecture part of this course will cover the ML concepts such as the different types of ML algorithms, data and feature engineering, metrics to assess the performance of different algorithms, building custom algorithms, and concepts such as production monitoring of ML pipelines. Here is a sneak peek into the tools we'll cover in this series. We'll learn how to process or feature engineer a raw dataset to a form that makes it possible to train an algorithm. We'll do this using a hands-on exercise on different datasets. We'll then upload the dataset to S3, following which you'll configure a SageMaker training job. We'll learn how to configure the various parameters of this job, including instance types, input and output data configurations, model hyperparameters, etc. Following this, you'll create a SageMaker endpoint to enable making predictions. However, this is not available externally and hence you'll need to connect it to an API gateway to ensure you can trigger the model for prediction. To accomplish this, we'll configure a AWS Lambda and an API gateway to create a microservice with a REST URL. We'll configure several IAM roles that will ensure smooth interaction between different AWS tools that we are connecting. You'll be building several complete end-to-end ML pipelines in the Amazon cloud as a part of this series. At the end of the course, you'll be able to map a business problem to an AI and understand and build the full stack of an ML pipeline, starting with a dataset all the way up to deployment of a microservice, which one can interact with using a standard REST API. You'll know how to monitor and maintain a ML pipeline once it has been deployed by iterating over it. You'll also understand the production best practices and the rules of compliance to keep in mind when building one. You'll also be building a custom project where you build an end-to-end working ML pipeline to solve a problem that you care about. Past students have built and published their projects on things like GitHub, blogs like Medium, and KD Nuggets. Here are some examples of the projects that were built by previous students. I look forward to seeing you in the course.